Hi everybody, I'm Dusty. I'm from Discovery Lab in Tulsa, Oklahoma, and I'm here today to do an experiment with you guys. So our experiment is going to be about chemistry. So for those of you guys who don't know, chemistry is a branch of science where we study how different things would interact to create matter, how we can then recombine them and make new things. So if you want to do my experiment, you're going to need to grab a few supplies. First thing, you're going to need some baking soda. If you don't have baking soda, you can substitute baking powder, or if you have antacids. However, if you do use those, you're going to need to use more than what I'm going to use. The next thing you're going to need is some vinegar. If you don't have vinegar, you can substitute with lemon juice, lime juice, orange juice. Any good citrus juice will work. Again, if you do use orange juice, you might need to use more than I'm going to use. Then you're going to need a bottle. Your bottle can be any size, any shape. A smaller one works better, and you're going to want a pretty small opening or mouth. You don't want it too big. You want one that's going to be a bit smaller, like this one right here. The next thing you're going to need is a balloon. It can be any size or shape. Just make certain that it is whole and doesn't have any little punctures or anything in it. Then you're going to want to have a baggie. Now, I can use a sandwich baggie, a snack baggie, doesn't matter the size or shape. Just make certain that it doesn't have any holes in it. It needs to be airtight, and make sure you get one that you don't mind throwing away whenever we're done. Then, you're also going to need some paper towel. If you don't have paper towel, you could use toilet tissue, you could use tissue paper, just some nice thin paper. That'll work fine. You're also going to want a funnel to help us move things. If you don't have a funnel, you can make a funnel by taking a piece of paper and rolling it to a cone with a little hole on the end of it, so that way you can use that. I'm also going to keep a towel around because we might get a little bit messy and I won't be able to clean stuff up. So why don't you guys go grab your supplies, and I'm going to talk to you guys a little bit about reactions. So how many of you guys have ever heard the word reaction? Bet a lot of you guys have. But what does a reaction mean? Well, a reaction is what happens as a consequence or an effect of one action. So, for instance, if I hit the first domino in a row of dominoes, the reaction is that it'll knock the next one, and the next one, and the next one, and the next one on down the road. In science, we can classify reactions in two ways. We can have a chemical change or a physical change. So, in a physical change, what I do is I change the shape, I change the status of it, the temperature of it. For instance, my paper right here. If I take this paper and I rip it like that, do I still have paper? Yeah, I've still got paper. It's ripped up into two pieces. If I take it and I crumple it all up, well, I've changed the shape of it now. It's in a ball, or I could pull out a marker and I could write on it. Now its color's different, but the chemicals that make up this paper have never stopped being paper. Similarly, if I take some water and I put it in the freezer, it will solidify and turn into ice. But if I take that ice out of the freezer, it'll melt right back down to water. It can go back and forth. So those are all physical changes. However, in a chemical change, I change the chemicals that actually make that matter up to make something new or different. So for us to go back to my paper right here. So let's suppose I take my paper right here, and instead of wadding it, I light it on fire. Now, my paper is slowly turning into not paper. Instead, it's turning into flame, it's turning into smoke, it's turning into ashes. So as my paper burns, the chemicals inside the paper are being converted into this energy, this light, this heat. And you can see I have all this smoke coming off of it. I'm going to have nothing but some gray ash left over. But then you guys will see I don't have any paper left anymore. All I have left is ashes, dry, dusty ashes. I've changed the chemicals inside my paper into flame, smoke, and ashes. And I can't put that in the freezer and freeze it back down into paper. So, hopefully you guys have grabbed your supplies and you're ready to do our experiment. Alright, so what you're going to do is you are going to grab your bottle. I'm going to be using this guy right here, so it's real easy for y'all to see. Next, you're going to grab your baking soda. So if you didn't have baking soda, remember, you could use baking powder or you could use antacids. And if you're using those, you want to double up. You want to use twice as much. Then you're going to grab your vinegar. And remember, if you don't have vinegar, if you don't have regular vinegar, you can use apple cider vinegar, you can use lemon juice, lime juice, orange juice will work in a pinch if you don't have that. But if you do use orange juice, you probably want to use twice as much. You're going to grab your balloon, and you're going to grab your funnel. Remember, if you don't have a funnel, you can make a cone out of paper to use it. So, take your balloon, and if you have trouble with this, maybe have a bigger person or a friend or someone help you. Stretch your balloon over the top of your funnel, like so. So it's on there nice and tight. Now, I'm going to put a spoonful of baking soda, a nice big hefty spoonful, into my balloon. And I'm going to kind of shake it down right there until my balloon is just about full of my baking soda. Then I'm going to pull it off right there. Now, I have got a balloon full of baking soda. Set that down right there. Then I'm going to go to my bottle. I'm going to pour about a ½ cup of vinegar in here. I've got it already measured out right here. If you guys don't get exactly a ½ cup, don't worry. It's okay. Pour that into my bottle. All right. Now this next part can be a little bit tricky. What you want to do is you want to put your balloon over the top of your bottle without dropping the baking soda in. So what I like to do is I like to get 2 hands and really get it nice wide and open, and then keep the baking soda tilted down so it doesn't get in the bottle yet. And now I've got this stretched tight over the top where it's nice and airtight. All right, so yours should look a little bit something like this. If it doesn't look like this, that's all right. Mine's different than yours. I'm going to show you sort of what yours might look like on this bottle. Your balloon will be hanging down like that, your vinegar will be inside, and your baking soda is inside your balloon. All right, you guys ready to set this off? All right, now use one hand to hold on to your bottle, and use the other hand to grab the top of your balloon. And as quickly as you can, try and dump all that baking soda in your vinegar, like so. Shake it down right there, and we'll notice a lot of things start happening. So what we're going to do is we're going to investigate, and we're going to see what all we can see. So the first thing I'm going to do is I'm going to use my eyes. What do I notice happening? I can see a lot of things changing right here. If I look down here, I can see a lot of things changing as well. I'm going to use my ears. I'm going to hold this up close. Ooh, I hear some things happening. Do you guys hear anything happening with yours? Now, I'm going to use my nose. Do I smell anything? I don't smell anything. Maybe you guys do. Now, I'm also going to use my hands to feel. Feel the bottom of your bottle. Feel the sides of it. Does anything feel different to you? All right. So, what do you guys think? Did we just do a chemical change, or did we do a physical change? Well, guess what? We actually did a little bit of both. The first thing we did whenever we added our baking soda and vinegar is we did a chemical change. We created brand new chemicals. My baking soda and vinegar created a gas known as carbon dioxide, CO2. That's also the gas you guys breathe out whenever you breathe. Gases take up more space than liquids, like my vinegar, or solids, like my baking soda, because they bounce around a lot more. Now, because they bounce around a lot more and take up space, they have inflated my balloon a lot. So if I can take my balloon off nice and gentle like this, I've actually got a balloon full of pure carbon dioxide, or CO2, right there in that balloon. Now, guys, thought that the balloon rising was a physical change. You're right. My balloon is still a balloon. Even though inside of it is CO2, my balloon hasn't changed. It's still a balloon. So this guy hasn't changed. What's inside him has changed, but he is still the same. He got bigger or inflated because I added things to him, but he is still a balloon. Now, how many of you guys felt something different whenever you held the bottle? Did it feel hot? Did it feel cold? Probably felt it get colder. That's because because this reaction is an example of an endothermic reaction. Now, an endothermic reaction, that means that it actually gets colder. Things like fire get hot when they make reactions. That's because they release energy. However, in an endothermic, like indoors, it means that the heat goes inside and has to suck in heat energy in order to make that reaction. You also probably saw a lot of bubbling and fizzing going on in here. That's because we were making those CO2 bubbles inside this liquid. Did it look like something you drank before? Has anyone ever had a soda pop and really looked at the bubbles? Those bubbles inside your soda are actually the same gas in here. Carbon dioxide. That's why it's called carbonation, or a carbonated drink. Now, this right here doesn't have sugar or flavor in it, so it's not going to taste like a soda. The bubbles are the only thing that's the same. All right, you guys ready for another version of this experiment? So what I'm going to do is I'm going to set the guy aside. Now, I'm going to grab my baggie right here. So I'm going to take my baggie, set it down, then I'm going to grab a paper towel. Try and get just one nice one, doesn't have any holes in it, you don't want it to leak yet. Then I'm going to take and get another scoop of my baking soda. And I'm going to lay it down right in the middle of my paper towel. And then I'm just going to kind of gather it up nice and neat. You don't have to make it too funky. Just kind of got it gathered up here. So you can see I've got it all gathered up inside this paper towel right here. Set that guy down to the side. Now, I'm going to take my baggie, and be very careful with this. You don't want to spill, because I don't know if you guys have ever got vinegar all over the place. It doesn't smell great, so you don't want to make a mess. So I'm going to take and I'm going to open my bag and try not to rip it. I am going to pour my vinegar inside my bag. Hold it down on the table if you need to make certain. All right, so my vinegar is inside my bag. Now, whenever I did this one, my balloon kept all the air from escaping. For this one right here, I don't want any of my air to escape. So that's why I have isolated or kept apart by using this paper towel. My reaction isn't going to start until the vinegar actually gets through my paper towel. Now, you have to be extra quick with this one to make certain you do it right. Whenever we do this, we want to zip it really, really tight. So whenever we're zipping, I like to start from one end and zip it, and then go back to the other end to make certain I got those corners zipped. And then my bag is watertight, it doesn't leak. You don't want any leaks, guys. So if you need someone to help you with this, have someone help you. And you've got a few seconds to get it done, but you want to be as quick as possible. All right, you guys ready? So I've got my baggie of vinegar. I've got my baking soda wrapped up. I'm going to set it in right here and zip it up tight. And I'm going to give it a little shake right here just to mix all that baking soda and vinegar really well together. And oh man, see how it's swelling up really big? Oh my gosh. Look at how that thing's getting bigger and bigger and bigger. If we're making that carbon dioxide, it's converting into a gas. And oh man, that one's swollen up huge. And as it converts from that liquid and that solid, remember, gases take up more room, more space, because they have more energy. They want to bounce off. Oh! Oof, mine burst. Did you guys burst too? Well, make sure you be careful with it and try not to get any messes anywhere. That's why we keep a towel around so we can wipe things down. Definitely don't want to make any messes. So, how many of you guys thought that was pretty fun? How many of you guys are really worried that yours is going to explode all over the place? Did anybody's explode all over the place? What do you think? Was it more funny or more scary? Well, that's all right. So, how many of you guys enjoyed doing this experiment with me? I hope you guys did. I like doing this experiment a lot. I want to know, what are some thoughts you guys have on this experiment? How could you make it different? Could you make it bigger? Could you make it better? I have an idea for you guys. If you want to do this differently at home, you'll need a scale. So, my idea for you guys is, if you have a small scale like this, a little kitchen scale, weigh your equipment before you do the experiment and then after. Do you think it's going to weigh more or less? Did we lose weight because I made air? Or did it get heavier and gain weight because my balloon swelled up? What do you guys think? More, less, or maybe it'll weigh the same? That's a way you can take and expand this experiment at home. All right, do you guys want to see me do it? I bet so. So I'm going to grab one more balloon. I'm going to put it over my funnel, get one more scoop, dump it in right there. So, you guys remember those 3 states of matter I was talking about? Solid, liquid, and gas? Now, the way that those work is, as we change states of matter, we add energy. And as we add energy, the particles, or the little parts of matter, they move around more. How many of you guys have ever boiled water? Maybe for making macaroni and cheese, maybe for making mashed potatoes, maybe for making tea. Whenever you add that heat energy to your water, it starts to move around a lot, and it turns to steam, and that steam goes up and everywhere. As we add more energy to things, they want to spread out and start to wiggle around and move a lot more. As we take away energy, or as we cool them down, they want to shrink down in closer and closer and closer and closer. So they go from gas all over the place to liquid to solid rock right there in the middle, like ice. All right, so what I'm going to do is I'm going to turn on my scale. I'm going to set up my experiment. Then I'm going to set my bottle on top. And let's see, how much does this weigh? Let's put it in grams. It says it weighs 171 grams. So what do you guys think? Is it going to weigh more, less, or the same after I do my experiment? Let's see. All right, so 171. So I'm going to grab it, flip it up and shake it down, and then I'm going to let it go. My balloon's getting bigger and bigger and bigger. But my scale still reads 171 grams. It didn't lose or gain any weight. That's because all those little particles, all those little pieces of matter are still here because of what's called a closed system. No air could get out, no air could get in, nothing could move in and out of this bottle and this balloon, so everything that was inside of it is still here, just in a different form. So, this is an example of the law of the conservation of mass, which says that you can't create or destroy mass, you can only change its state. So, how many of you guys like doing experiments like this at home? What do you think would change if you used some of the substitutions that I told you about? Did anybody use the substitutions? Did anyone use lemon juice? How about orange juice? You know, I bet if you tested, you could find that there's actually a lot of juices that do this. The reason why this experiment works is because this is an example of an acid-base reaction. So, vinegar, lemon juice, orange juice, and lime juice, and a lot of other things are all examples of acids. Now, whenever we're talking about acids and bases, we have a scale we call the pH scale. It runs from 14 to 1. Down at the very bottom on 1 is what we call our acids. So the closer something is to 1, the more acidic it is. So all the way down at 1, we have things like battery acid, stomach acid. Have you guys ever heard of any other acids? I'll bet you have. So as we go closer and closer and closer to 7, our acids actually get weaker and weaker and weaker. That's because 7 is right in the middle, and it's called neutral. Neutral means it's not acid, not base. Have you heard that word neutral before? Maybe you have. Maybe you've heard of it whenever you're talking about a car. If it's not in drive and it's not in reverse, it could be in neutral. If you're not for one or the other, you're neutral. So, pure water is neutral. Now as we go up, we get more and more basic. We have stronger bases. Now, a lot of things that we consider bases are cleaners and soaps. If you've ever heard of ammonia, that's a base. Baking soda, we can use to clean. We can also use washing soda or detergents, and those are generally bases as well. That's because a lot of our food is acidic. Did you guys know that? even things like tomato sauce are technically acidic. That's why we want to clean them with bases, because whenever they react together, they neutralize or they cancel each other out to make each other closer to water. Now, you might be wondering, well, how does baking soda and vinegar turn into carbon dioxide? Well, the answer is, if we could look at the chemicals or the elements, actually, that make up baking soda, we would see a lot of things. Baking soda is called sodium bicarbonate, which means it has carbon in it. So, do you remember what we called it CO2? Carbon dioxide? So it's already got the carbon inside of it. Vinegar, believe it or not, is actually mostly water. Vinegar that I have here is about 95% water. The other half is an acid. Now that acid is called acetic acid. If you guys were using something like lemon juice, you probably had something called citric acid inside of it, which is still an acid, and so it's going to react. When those acids react with our bases, the carbon that was stuck inside the baking soda reacts with oxygen that was stuck inside of our acid, and then they mix together to create our CO2. How many of you guys like to play with Legos? Or any other type of building material? I'll bet you guys do. If you only had 100 Legos, could you only make one thing? Could you make 10 things? Or could you make pretty much anything? Believe it or not, almost only 100 elements exist. There's a few more, but they're very rare and they don't even last very long. But out of those 100 elements, we can build everything. You, me, the sun, grass, trees, animals, cars are all built out of those 100 or so building blocks. We just rearrange them, stick them together in different ways. So that's how we can take and make new creations from the same elements. Well, hopefully you guys didn't make too much of a mess. I luckily enough didn't make a big one. If you made a mess, make sure you clean up. Don't want to leave any messes. So, hopefully you guys had a lot of fun hanging out with me here at the Discovery Lab. Before I leave, why don't we go over some of the things that we learned today? First of all, reactions. A reaction is something that happens as an effect of one thing happening. We have two different types of reactions in science. We can have a chemical change or a physical change. In a physical change, my chemicals remain the same. Their shape just gets changed or their temperature gets changed, like crumpling up paper or freezing water to make ice. In a chemical change, the chemicals are actually made into new and different things. I even lose some of the stuff I started off with. For instance, burning my paper. Whenever I burnt it, I had smoke and ashes, but I didn't have any paper left over. The next thing is acids and bases. Remember, acids and bases are on a pH scale. The pH scale goes from 1 to 14. Closer to 1 it is, the stronger the acid. The closer to 14 it is, the stronger the base. At 7 in the middle is neutral. The closer it is to 7, the weaker the acid or the base it is. Remember, our 3 states of matter. We had solid, liquid, and gas. Solids are the ones that have the least energy. They stay stuck together really closely. Liquids, like water, can move a little bit more. Gases, when they have all the energy, they're bouncing and moving all through the air and everything. Remember, our law of conservation of matter. We can't make or destroy matter. We can only change the way it's put together. Just like breaking apart Legos and sticking them together in new and different ways. Well, all right, guys. Thank you guys so much for hanging out with me. I look forward to seeing you guys next week. We'll have a whole new experiment for you guys to try. I've been Mr. Dusty at Discovery Lab in Tulsa, Oklahoma, and I look forward to seeing you guys again.